I'm starting a new series called Mastering Spring AI to teach how we can leverage generative AI capabilities in our Spring Boot applications. First, let us talk about what we are going to learn in this series. Generally, when we talk about AI, for different people, it can mean different things. For example, there is an aspect of machine learning where they train the models, and this is not the focus of our series. And then there is AI powered coding, like there are tools like JetBrains Juni, AI Assistant, or Cloud Code, Gemini CLI. So these are all the tools that you can use to speed up your application development. This is also not the focus of this series, but while going through our series, we may leverage some of these capabilities. And finally, this is where our focus is, like building AI powered applications. Just imagine we are building a travel agent application where we can recommend users to plan from one place to another, travel, and how many days you can plan for a trip and all that. So there we can leverage these AI capabilities. And if we are going to use Java-based applications, there are a few alternative frameworks that can help you to build the applications, AI-powered applications. The prominent ones are Spring AI and LangChain for J. In this course, we are going to focus on using Spring AI. So this is the focus of our series. And finally, you can ask, why Spring AI? Why can't we directly use various AI models? So here you can see there is OpenAI and Anthropic, Google Gemini, Azure OpenAI, and there are many more such AI providers. So here most of them also provide direct SDKs. Like if you are building an application using Java, there is a Java SDK and TypeScript SDK, Python, Go. So they kind of give SDKs for most of the programming languages. But if you directly use those SDKs and build your application, you may not get the portability. Like let's say you start with OpenAI, but then you see it is not performing very well and you want to switch to another provider like Anthropic, then your code is not portable. So this is where Spring AI come into picture. Spring AI provides a higher level abstraction over all these models where you can build your logic in such a way that with minimal to only configuration changes, you will be able to switch from one provider to another provider. So that is why we are going to leverage Spring AI to build the AI powered capabilities. So that is the idea of this course and what we are going to cover in this series. So first, we are going to get to know how to use Spring AI to interact with LLMs like OpenAI or Anthropic models. And there are many other providers that are compatible with OpenAI. So you can just use OpenAI starters and still with some configuration changes, you will be able to talk to different LLMs as well. We are going to see that. And then we will see how we can leverage various prompt templates and how we can get a response in a structured format. Let's say you ask an LM a question and you want the response to be in a JSON format and you want the response to contain a specific set of fields. Instead of giving a general text, you can get some structured outputs as well. So we'll see that. And also chat memory. Let's say we are building a chatbot, and while interacting with a user, obviously we should remember the conversation, at least some conversation, so that you can respond in a meaningful way. So we'll see how we can implement that as well. And finally, um, our LLMs doesn't have all the data. There is a knowledge cutoff time, and also it may not train on our own data as well. So there are techniques like RAG, and by using embedding models and vector stores, we can augment the data that we have, and then we can chat with the documents or we can leverage that additional context to get better responses from LLMs. So we are going to see that. And there is a tool calling capability, which means LLMs have whatever the trained knowledge, but sometimes we may need additional data. Maybe we want to talk to some REST API and get additional data, or we may want to invoke some other process to do some activity for us, like creating a calendar event or something like that. So for these kind of a task, we can leverage this tool calling capability that can extend what our LLMs can do. And finally, there is a model context protocol, which we can integrate with many MCP servers, or we can build our own MCP server. We can use MCP clients. So we will learn how we can build MCP servers and clients by using Spring AI. So this is the overall course that we're going to cover. And I hope this is going to be very helpful as going forward. I hope many of the applications are going to leverage these AI capabilities. We're going to start with implementing a simple chat application talking to OpenAI. Welcome back. In this episode, we're going to start building our first application to talk to OpenAI chat models. Before doing that, first we need to create an account on OpenAI platform and create an API key and set it as an environment variable. So in order to do that, first we should go to platform.openai.com and register. You can use social login. And once you log in, you can see API keys in the organization level or at the project level. So come here and create a new secret key. So I have created my secret key. Now I can take this value and set it as a environment variable so that we can reference these environment variable values instead of hard coding the sensitive information in our application. But one thing to remember, in order to use this OpenAI API key, either you should have a subscription to the OpenAI or you can add some credits. I think minimum you should use $5 and then you can get some credits. So otherwise, it's not going to allow you to use this API key and make calls to LLMs. So once we have this, we can go ahead and create a Spring Boot application and see how we can interact with the OpenAI LLMs. Here, first I have created a plain Maven project. And if you notice, we have packaging type POM, which means this is a root Maven module, which may not contain any code itself, but we are going to create sub modules, and each module we can demonstrate various Spring AI capabilities. So this is a basic setup we have, and now we can go ahead. If you are using IntelliJ Ultimate Edition, we can directly create a module and select Spring Boot, and you can go ahead and select what are the starters you need and create a module here. If not, you can go to Spring Initializer, start.spring.io, and here select Java language, Maven build tool. Of course, you can use Gradle if you like, and provide this project metadata. I'm going to use Java 24, but anything from Java 17 onwards works fine. And here as starters, I have selected web and validation. These are typical for REST APIs and for bean validations. Now we are going to talk to OpenAI, right? So let's check for OpenAI. And there are Azure OpenAI and just OpenAI. So I'm going to select OpenAI, and we can generate the application and unzip it and copy that into our parent project. I have copied the generated project into root module here, and I'm going to add that as a module and refresh. So now it is one of the module here. We have, let me clean it up a little bit. So apart from OpenAI dependency, rest it is typical Spring Boot application, and there is a Spring AI bill of material dependency added. That's it. So now we are going to configure OpenAI properties so that it knows to which model it needs to talk to and all that. And also we need to pass OpenAI API key. Now let's configure the OpenAI configuration properties. So here you can notice we have configured the base URL, API key, and chat options model and temperature. So if we are talking to OpenAI, this is the default base URL. We don't even need to explicitly configure that, but this is the important API key configuration. We have already configured a environment variable with this name by setting the value to actual API key. And this is how we can specify what chat model we want to use. So if you want to use older models like GPT-4o or Mini or something like that, you can specify it. But I'm going to use the latest GPT-5 model. And one important property is temperature, which is whose value should be between 0 to 1. So usually the higher the number, the response would be more creative and random, and the lesser the number, it is going to be more deterministic. And an interesting thing to notice is if you are using older models like GPT-4o or something like that, you can configure a different value. But GPT-5 seems to be supporting only temperature value 1. So we have configured that. And next, let's create a chat controller. So here I am creating a chat controller, which is nothing but a REST controller. And here in the constructor, I am trying to inject this chat client builder, which is going to be auto-configured by Spring AI. And inside the constructor, I'm simply calling the build by using all the defaults, and I'm instantiating the chat client instance. So if you want to provide any other customizations, you can do that. You can specify what is the default system prompt. And if you want to specify any advisors that we are going to talk later. So all that customizations you can do here, and the chat client can be used to make a call to LLMs. So here is one interesting thing. Let's say you have multiple such controllers and you want to initialize chat client with different customized configuration. You should be doing like this. Otherwise, you can create a configuration class and try to provide a bean instance by taking the builder and then doing all the customizations and then exposing that as a bean, and you should be able to directly inject that chat client instance itself. But for now, let's go ahead with this approach itself. And here we have a post API endpoint, and we have a input record, output record. For the input, we are simply taking the user prompt, which should not be null, should not be blank. And once we have the user prompt, we are calling chat client.prompt and pass the whatever the user entered prompt. And here we are making the call. And once we got the response, we are calling this content method, which is going to return the LLM response as a string. In addition to this, there are different ways to make the API call here, but this is the simplest way to make a call to LLM. So once we got the response, we are simply returning the response as output of content. So it is the simplest implementation we have. Now let's start the application. And the application is started. Now you can use any client like Postman or anything like that. But here in IntelliJ, I have a HTTP console itself client. I can make the call to the API chat endpoint. And here I'm specifying the prompt as what is springboot. Let's see what LLM is going to respond with. So here you can see springboot is an opinionated framework built on top of Spring ecosystem. So we got the response from OpenAI LLM. So we have built a simplest chat application. I would say it's kind of a hello world of AI based applications. An interesting thing is Spring AI is internally taking care of making REST API calls to the LLM models and all that. But if you want to know what is going on behind the scenes, what kind of inputs our application is sending to LLMs and what kind of a response we are getting, a simple option is to inject an advisor to this chat client so that it's going to log what is the input we are sending and what is the response we have got from LLM. And if you know from the Spring framework itself, advisor is kind of a terminology from AOP, which is going to intercept the request and add the custom logic. And once we got the response, we can add some more logic. So out of the box, Spring AI provides this simple logging advisor, which is going to log the input request and responses. So once we set this, we also need to enable log level for this. So here, ORG Spring Framework AI Chat Client Advisor, set it to debug. Okay, now with this configuration, let's start and again make the API to the same API endpoint. This time we can see, so our logging advisor log this chat client request, which contains, so what is the prompt message? The user message is what is Spring Boot, and it also specifies other properties like what is the model we are using and what is the temperature we set. So all the inputs that we are using for making a call to, it is logged. And also once we got the response, we simply extracted the actual text response. But in addition to that, it also returns a lot of other data, like what is the model used, and how many tokens are used and all that. So if you want to check what is going on behind the scenes, this is the simplest option that to enable this advisor, and you will be able to see a lot of data that is going on behind the scenes. So basically, this is the response we just extracted. But in addition to that, there is a lot more things going on. So I would say this is enough for this episode, that we get to know how to make a call to OpenAI by specifying the properties like this, and we are able to chat with OpenAI. In the next episode, let us see, instead of talking to OpenAI itself, there are other OpenAI compatible LLMs like Groq, even Gemini. They gave OpenAI compatible APIs. So there are a lot of options that are compatible with OpenAI, and we're going to see some of them, how to talk to those LLMs. Welcome back. In the previous episode, we have seen how we can interact with OpenAI LLM models. However, to use OpenAI LLM model, either we need to have a subscription or we need to buy some credits. It's not completely free. So there are some OpenAI compatible LLM models that are free to use, and you don't need to change any code. Just by changing the properties, you will be able to talk to these different models. So here I have listed few OpenAI compatible LLMs that I am aware of. Gemini, Groq, OpenRouter. OpenRouter is not really a LLM in itself, but it acts as a facade and then provides a compatible OpenAI compatible API, and it delegates to other models, even non-compatible, non-OpenAI compatible models as well. And finally, there is Docker Model Runner. You can install Docker Desktop, and then you can pull the models from Docker Hub, and you will be able to run the models locally, and you can talk to them. So these are the options that I am aware of. If you know any other OpenAI compatible LLMs that we can use for free, please let me know in the comments. So for our learning purpose, I think having some free options is good. So let us see how we can use all these options from our Spring AI application. Previously, we have this root Maven project and the first module, and I have copied the exact same module with a different name, 02 OpenAI Compat Chart. And I have same chart controller that we have used in the previous module itself. And this is a typical springboot main entry point class. And if you take a look at the application properties, also it contains the same properties that are configured to talk to OpenAI itself. So as I mentioned, the alternative LLM models that I just mentioned, they are OpenAI compatible models, which means you don't need to change any code. By simply changing these properties, we should be able to talk to those different LLMs. Now, let's start with Gemini. So in order to create an API key, here in this README, I have mentioned all the URLs where you can create API keys. So for Gemini, what you can do, there is aistudio.google.com. So if you go to Google Studio, if you go to Google AI Studio, you can click on this Get API Key, and here you can create an API key. And similar to OpenAI, it will generate a random string which you need to take, and you can set an environment variable with Gemini underscore API underscore key. Once you have this, you can go to here, you can create a profile specific properties file, application-gemini.properties. So here I have changed the base URL talking to Gemini LLM URL, and then completion spot. This is nothing but the API endpoint where you invoke to have a chart. So for OpenAI, it is a different thing. For Gemini, it is a different thing. So here we have configured this. And for API key, we specified Gemini API key instead of OpenAI API key. and also the model Gemini 2.0 Flash model that I configured to use. So as I mentioned, simply by changing the properties, we are able to talk to a different LLM model here. Okay. So now what we can do, let's say we want to run this, and let me stop it. Now, instead of running with the default profile, I would like to run with Gemini profile. In IntelliJ you can go to edit configuration, and here you can specify active profile as Gemini, like, and run. So here you can see I have Spring Debugger plugin installed. So here you can see all the rest of the profile specific property files are grayed out, but only default application.properties and application-gemini.properties are highlighted, which means they are loaded. Okay, now if you take a look at the application properties, here you can even see the different values. We are talking to Gemini APIs, not with api.openai.com. Okay, so now we have everything ready. Now let's go to HTTP request, and let's make the same request. What is Spring Boot? So here we got response. As you can see, we have what is Spring Boot. It has written a bunch of text explaining what is Spring Boot. Instead of manually running the application and then triggering the API endpoints, let's write a test. It will be easy for us to check. So here I have written a simple integration test, and I have auto-configured mock MVC and injected mock MVC tester. In the previous versions, you might have used mock MVC. This is a better version of it. And we are triggering a post request to API chat, which is the one we have, API chat. And we post the prompt as tell me a Java joke. This is the prompt we are giving. And once we got the response, we are accepting the status should be okay, and converting the body response to JSON and converting that into output object, which is nothing but the response type that we are returning from this API endpoint. And we are accepting the content should not be blank. And also finally, we are simply printing that response given by the LLM. Now let me run this. And most importantly, here we are enabling Gemini profile using @active profiles. So here you can change which profile you want to activate. By activating the Gemini profile, it is going to override these OpenAI specific properties from the properties defined in this application-Gemini properties. Basically, instead of talking to OpenAI, it is going to talk to Google Gemini APIs. So we got the response. Let us see what Java joke it told. Why did the Java developer wear glasses? The good old same Java joke, because he couldn't see sharp. Fine. So that's how we can configure different LLMs, but still use the same OpenAI compatible API and talk to LLMs. So now that we have seen how we can use Gemini, let's see how we can use Groq. So Groq is kind of an alternative to OpenAI. Like they host the inference models, and then we can leverage these models. So you can log in, and of course you can use social login feature, and then you can log in. Once you log in, you can create API keys, and there are some models that you can use for free. So again, going to this README file, if you go to Groq config, you can directly click on this console.groq.com /keys, and it will take you to this page where you can create your API keys. So I have already created my first API key, and I take this secret key and set environment variable Groq API key. So again, the same story, I created another profile properties, application-groq.properties, And again, the same, simply change the base URL to api.groq.com, and completion path also different from OpenAI. So I have mentioned that. And instead of using OpenAI API key, I use my Groq key. And here is the thing, you also need to see which models that you can use. So basically, if you go here, you can explore the docs. Here, if you go to models, here you can see which one you can use. And I have picked one of the model and configured the model name in the chart options model. So now that I have this, I can again reuse the same test setup. Instead of using Gemini profile, I'm activating this time Groq profile. So here I can run this test. I'm asking the same thing. Tell me a Java joke. Let's see what Java joke Groq tell us. Why do Java programmers prefer dark mode? Because light attract bugs. The good old dad joke for Java programmers. So that's how simple we can talk to a different LLM called Groq. Okay, so now that we have seen how to interact with Groq also, you might already heard about DeepSeek, but the thing is, again, DeepSeek also provides OpenAI compatible APIs. However, just like OpenAI, you cannot create for free. You need to buy either credits or take subscription in order to use the DeepSeek API key. So I'm not going to do that, but you can see this DeepSeek profile properties. You can configure the base URL and specify the DeepSeek key and specify which model you want to use, and you will be able to talk to this DeepSeek. Okay, so that is it. And this is Open Router is another very interesting thing. Like as I mentioned, Open Router is not LLM provider itself. Let's go to this website. We'll get to know. So if you go to Open Router, you can see this is what is going to happen. If you ask anything, it will take care of routing the request to any of the models. You can specify which model you want to route to, but probably I think you can configure it in a way that it figures out to talk to a different model. So here, the interesting thing is it is not only for OpenAI compatible models. Here you can see it also redirects to Claude Sonnet as well, not only OpenAI models. So this is another feature that you can use. And again, here it is not completely free, but you can use it for free with free models. So if you go to models and if you search for free, these are all free. Let's choose Quen 3 coder, and if you come down, you can see what is the base URL, and you can specify Open Router key, and also here you can see the name, model name. So this is the model name. So like this, so once you log in into openrouter.ai, and here you can go ahead and create an API key. I have already created it, and let's see, I have created it and then set Open Router API key. Okay, now as I mentioned, you can go to the models and search for free and see what models are available that you can use for free. So I have taken one of the model that is available for free, and I have created this Open Router profile properties application hyphen open router.properties, and the base URL is changed to openrouter.ai, and instead of OpenAI key, I am using Open Router, and completion path. And here I mentioned a couple of chat models that are available for free. You can use any of them, and I am configuring one of the model. And the interesting thing is, earlier I mentioned DeepSeek. If you directly want to talk to DeepSeek, you need to have some subscription or have some credits. But through Open Router, you can configure to talk to this DeepSeek model itself, and that is free. And you can configure one of these models. Now let us go ahead and test with that. Now we are enabling open router profile. So now here you can see it is talking to Quen 3 model. Oh, the same joke. Why do Java developers pair classes? Because they don't see sharp. So that is how we can use all these models, and there will be, of course, some usage limitations. You cannot use it crazy, but there are limitations. But as I mentioned, for our learning purpose, that is good enough. And finally, let us take a look at how we can use Docker model runner. Finally, let us see how we can use Docker model runner. And if you click on this link in the README file, you will see how we can set up Docker model runner in our Docker desktop application. So here I have Docker desktop running. And if I go to our dashboard, here I can see all the containers and images and everything. And if I go to settings and beta features, here I can enable Docker model runner and also enable host side TCP support. Okay. So once you have enabled this, probably you need to restart. Once you've done that, here you will see these options, models, MCP toolkit and all. If you click on these models, here it is already showing the models that I have already pulled. Otherwise, you can click on this Docker Hub. Here it will show all the models that are available on Docker Hub. You can pull one of the model based on your system configuration. You may need to pull some lighter weight model. And I have already pulled these models. So now I'm going to use one of these models and configure my application to talk to these models. So here, if I go to my code and open the application -dmr.properties, dmr Docker model runner, and I specified base URL to localhost 123.12434. That is nothing but, okay, here again to check, that is nothing but the port that, click here, beta. So here, this is the port. Okay. So we have configured this, and it doesn't need any API key, but we cannot leave it empty. So I just put underscore, but it doesn't matter what value you enter for this API key while using a Docker model runner. And the model I am trying to use is AI/small m2, which I already pulled here. So we have everything. Now again, I'm going to run the same test. This time I'm going to enable this DMR profile. Let's run and see. So basically you need to have some decent size machine to have the RAM and everything so that these models can run smoothly. If we take a look at the response is, what do you do if you have a brain tumor and no one knows what to say? Take a bite out of this. Fine. Whatever. I don't understand this joke. If you know, let me know in the comments. We have seen different alternatives to OpenAI LLMs by leveraging the compatible models. And I guess this is really good for learning purpose. And as I mentioned, if you know any other alternatives, please let me know in the comments. Welcome back. In the previous episode, we have seen how we can use OpenAI compatible models, and that too, there are few free options. In addition to those, we can also install the tool called Ollama, and you can pull the available models and you can use them from your Spring Boot application. So let's see how we can use Ollama models. If you go to ollama.com, here you can see, you can click on this download button and download the installer based on your operating system and install it. Once you install the Ollama tool, here you can go to the models and see all the models that are available. And based on your system resources, you can pull one of the model, because there are many options. For example, if you take GPT OSS, there is one option 14 GB and another one is 65 GB. So based on your need, you can pull one of the model. And there are many models available, and you can also see which models support what kind of features. Here it supports Qwen 3 supports tool calling and thinking models. So based on the need, we can pull any number of models. And one good thing is earlier Ollama was not giving any GUI feature, but in the recent versions, once you install it, it also provides a nice GUI client. So here, when I open the Ollama, here you can see this is a macOS GUI application. And this dropdown also shows what are all the models that I already pulled. If you want to pull something new, you can search. So here I just search for deep, and this model is not already pulled into my local system. So here I can click on this and it will pull, and then we can chat with them. So now I can select, let's say I would like to talk to Qwen 3 8B, which is already pulled. Now, okay, let me ask what is Spring security? A very lame question, but just to make a point. So here we can ask any question. So it is going to start that model behind the scenes if it is not already started, and then have the conversation. We can talk to it, and then you can see first it is thinking, and once it consolidates its response, it's going to give the response back. So let's see. Okay. So here it is thinking for 11 seconds and so, and then it is giving all this response. So the good thing is, even if you are online, you can, once you install, all that knowledge is there locally, and then you can use it for free. So now that we have Ollama installed and we have this Qwen 3 8 billion parameters model running locally, let's see how we can interact with it from our Spring Boot application. So similar to previous examples, I have taken this chat OpenAI model, OpenAI submodule, and copied that into chat Ollama. The only difference is earlier we have added starter model OpenAI. Instead of that, we need to add this Ollama starter. Even if you go to Spring Initializer, you can select Ollama, and that is going to add the same dependency. So I have simply generated that, and I have reused the same code that I have earlier. There is nothing changed here. And also the same chat controller, we have one API endpoint, we simply send a prompt and then we are getting the response. Nothing changed. And the change is in the configuration. So here earlier we have used OpenAI base URL, which we don't need to configure, but we configured the API key. Here it is a local model running on my system itself, and there is no need for API key, so we don't need to configure any API key, but we need to specify which model we want to use. So here I have downloaded this Qwen 3 model already, so I configured this, but there are many models as I shown. You can download and use any of those models, and here I just configured the temperature, and this configuration you are already familiar with. So with this we can start our application. And similarly, we can make an API call, and again it's going to think for some time and then it's going to respond. Meanwhile, another thing is you can also interact with the Ollama thing from terminal. So here, once you install, you have this Ollama CLI tool installed. There is many commands available. Ollama help. Here you can see all these commands are available. So for now, let's say we want to see what models are already pulled into local. So here I have all these models already downloaded. Okay, so similarly there are many other commands list running models. So let's see PS So Qwen 3 model is currently running. So you can interact with this. Also, instead of using the GUI, you can also pull any model that you would like using Ollama pull command. So you can do all those things from CLI itself. So here we can see we got the response. Here you can see it is not only giving the final response, it is also including the thinking part of it also. So this is one more thing we need to consider, like actually we don't need that thinking part, we just need the actual thing. So this is where some prompt engineering techniques come into picture that we'll talk later. So we are able to talk to one of the Ollama models and then get the response. I would say this is very nice. Being able to learn these concepts without having to spend the money. But again, in my experience, they are not as good as the OpenAI or Anthropic or some other models, but they are good enough to get started with. So I hope this helps you to experiment locally without spending money. And if you notice, the good thing is we have not changed any code. We are using the same chat client and the APIs are same only by simply changing a starter and configuring different options. We are able to talk to a different model. This is what I mean by Spring AI is providing a higher level abstraction so that you will have either no code changes at all or only minimal code changes and you will be able to talk to a different LLMs. So this is the benefit of using Spring AI. So I hope this is helpful, and in the next video, let us see how we can interact with anthropic models. That is another very popular LLMs, especially for coding tasks. So let's see how we can interact with anthropic models in the next episode. Welcome back. In this episode, we are going to see how we can interact with Anthropic's Claude models. Again, this is not very different, but I just want to show you like we can talk to different models. All we need to do is using the right starter and configuring those properties accordingly, and we should be able to talk to it. So it's going to be a very quick one. So first thing is obviously we need to create an account on Anthropic platform. And once you create it, you can go to this console.anthropic.com. And here, once you log in, you can see this API keys. And here you can create a new API key. So once you create that API key, go ahead and create a set a environment variable called Anthropic API key. So once you've done this, you can create an application that talks to Anthropic models. And here in our application, again, I copied one of the previous module and I changed the starter from OpenAI or Ollama to Anthropic. Rest of the code is same and the properties are changed. Here, as you can see, we need to set base URL, but the default is sufficient. So I have commented it out, and we need to set the API key. And here I have selected this Claude Opus 4.0 model. And if you want to see what are all the models available, again in the Anthropic documentation, there is models section where you can see what are all the models available and what is the model name you should use. Also, there is model aliases. Just for simplicity, they have provided the aliases which I am using. So these are the keys that you can use. Here I am using Claude Opus 4.0 and you can set the temperature, and this is the rest of the thing is exactly same. We have the same chart controller, and instead of running application and then seeing, I am trying to test through a test integration test. Again, we have seen this in the previous episodes. So this time I am going to ask Claude explain Docker in simple words. So let's run this and see what and how Anthropic Models is going to explain what Docker is. So here, let us see the response. So here you can see it explained all about Docker, like in the maybe a very brief explanation. So that is how simple it is to talk to Anthropic models. So this is it. Now you know that how simple it is to talk to different models by simply using the right starter and then configuring the properties. That's the major part. And programming model is pretty much similar as it provides a higher level abstraction. So now that we have some foundation, next we are going to talk about prompt templates, how we can use different ways of prompting. Welcome back. In this episode, we are going to learn about the prompt templates such as a message prompt, prompt template, and what are the various types of message types available. And finally, we are going to see how we can write effective prompts. So let's get started. So if you take a look at our earlier example of a simple chart, this is how we used to interact with the LLMs. By simply calling the chartline.prompt, we are passing the whatever the user prompt value is as a string, and then call the call method, and finally we get the response string by calling the content method. So it is the simplest way of interacting with the LLMs. But here we have not specified how the LLM should behave. So we are relying on the default behavior. We don't know whether it is going to behave like a professional chatbot or it's going to be a rogue behavior. We don't know. But most likely by default, they are going to respond in a professional manner as far as I know. But this is where you can tune your application based on the need of your the system you are going to build. You can define how the LLM should behave. So here, if you take a look at the code we have, so here I specify what is the system prompt. You are a funny and helpful assistant. You always respond in a sarcastic manner, something like that. Or you can specify you are a friendly, helpful assistant. You always respond professionally. So it's up to us how we want the LLMs to behave. And then we constructed system message and user message and then create a prompt and then call the LLM. But what are these system messages, user messages? So if you take a look at the prompt, it contains a list of messages. And also we can specify custom chat options, how the generation should work. But why it needs to be a list of messages? Shouldn't a prompt simply a string that we want, what are the thing we want to ask the LLM? But here it is a list of messages because here we are defining various types of messages, because when we are interacting with the LLM, what are the question prompt we are asking, that's a user message coming from a user of the system. And LLM may generate a message that can be considered as a assistant message. And also we are specifying the system message to define how the LLM should behave. And also when we ask anything to the LLMs, maybe they make another tool calls or things like that. So there are different types of messages. So that is why we have a message type that represents what kind of a message we have while exchanging a prompt. So here we have a user type message, assistant. This is like a response coming from the LLMs, and system is what the behavior we are setting for the LLM, and tool, a message of type function passed as input. So there are different types of messages. Mostly these tool, this message we'll get to know more about it while we are talking about the tool calling facility. So right now, to understand, a system message is to set the expectation of how the LLM should behave. And assistant is nothing but the LLM response. And user is our query. So based on that, there is some concrete classes. For example, system message, which is setting this is of type system. And again, if you take a look at the user message, it is of type user. So it is setting some base parameters for the message type. So this is how you can define a prompt to let the LLM know how it should behave, and you can create a user message by passing the user actual input, and then you can construct a prompt by passing the list of all these messages. And you can call the prompt by specifying this prompt object and then call the content. You may ask why we have a list of messages. Shouldn't it always be like there can be a system message and a user message? But by default, LLMs don't carry all the knowledge of the conversation. Every interaction is kind of treated as a one first call. So they don't remember the conversation history. So that's what we are going to see in the future videos, how to retain the conversation so that they can respond in a natural conversation style. So for now, think of you can create a prompt taking a list of messages, and now we can call this. So let's see how we can see the difference. Like, okay, first let us ask LLM to behave very professionally, and then I have a test making the API call, and I am asking why Java is so popular in enterprise software development. So let me run this test, and as we specified, it should behave in a professional manner. Now let's wait for the response. Okay, we got the response. So if you take a look at it, it's more like a professional response. Like Java's popularity in enterprise software development is combination of technical, practical, strategic factors and all that. You can see the professional terminology and all that. Platform independence, robust ecosystem. So you can see it is more like a professional tone. Let's change it to a funny and a bit sarcastic manner. Now let's run the same test again. So again, we got the response, and if we take a look at the response now, it is all the thinking part. And finally, Java, the language that's been around since 90s, like middle-aged uncle who insists on wearing a tie to be a beach party. Now you see the tone, right? It is mostly funny and kind of sarcastic, but hey, who wouldn't want to use it in enterprise software? So write once, run anywhere. Java's JVM magic lets you run code on any platform, assuming you have got a JVM installed. It's like having a universal remote for your computer, etc., etc. So you see the tone, right? It is mostly casual and funny because we set it to behave like a funny, sarcastic assistant. So that's how you can tune how the LLM should behave. And next thing to understand about the prompting is, earlier we have simply take whatever the user is giving and then passing the entire thing as a input to the LLMs. But sometimes maybe we have some a templating way of asking the questions, but only certain things change. Let's take an example of, let's say I want to give some presentation, conference talk or something like that. And I have some topic in my mind, but I would like to take the help of LLMs to come up with some good title suggestions. So here the changing part is, what is the topic that I want to give and how many titles I would like to generate for this given topic. So this is a pretty good scenario for using a prompt template. So here the prompt template, I created an instance of prompt template saying I would like to give a presentation about the following topic, and I use this placeholder and give me count title suggestions for this topic. Make sure the title is relevant to the topic and it should be a single short sentence. So here only these two things can be changed. And I can pass the variables to replace what is the topic and what is the count. So here we created a record taking the topic and count, and we are passing that and asking it to create a message. So it got a message created, and here we are saying prompt and then give the messages, and we get the response. So this is how, if you have some standard ask for the LLMs, but the certain parameters change, this is how you can use prompt templates. So let's see what we can ask, suggest titles. There is another test. So here, let's say I would like to give some talk about the Spring Boot tips and tricks, and I want the LLMs to give me some title sections. Let's say I want to have 3 sections. So here, let me run this test. So we got the answer. Here you can see mastering Spring Boot, essential tips and tricks. Streamline your Spring Boot projects with these pro tips, Spring Boot mastery tips to boost your development efficiency. So yeah, kind of a nice. So this is another way to use LLMs to assist you to come up with some suggestions and things like that. Here, if you notice, we are kind of hard coding the prompts or system messages in the code itself, but we can also externalize them into some class path resources and we can use them. Let's say we want to generate some interesting tweets based on the input we give. We know what to tweet about, but we want to enhance that content based on the LLM help. So I would like to create a tweet following certain pattern. For example, here I am creating a system prompt in this external file in the class path saying that you are an expert software developer and experienced content creator. Your job is to generate interesting tweet based on the given input. Use a catchy first line to convey the essence of the input. Keep it concise and engaging. Maintain a professional tone. Use bullet points to list key features or benefits. Use emojis where appropriate. Use relevant hashtags at the end. And we are also saying, because most of the times LLMs kind of generate markdown syntax based response, but here for the tweet we don't want the markdown syntax, so I'm saying use plain text format. So we have this class path resource file here, and I have injected that as a resource. So here I use the at value and specify the path, and it injected into this resource. Once I have this, here in this generate tweet endpoint, I am taking the content of that file and then creating the system message and take whatever the input user is giving and asking the LLM to come up with the response. In this case, we are expecting it to generate some interesting tweet for us. And again, let's see, I have a test for it. So here I have a test that says about prompt. IntelliJIDEA 2025.2 is released with a lot of new features such as Java 25 early access, MAM4, JSpecify for nullability check, Spring Debugger plugin, Spring Model support, and check out the blog post link for more details. So essentially this is the gist of what I would like to tweet, but I would like to enhance that to be more attractive. Okay, so let me run this and see what kind of a tweet content it is going to generate. So let's see the response. So here you can see kind of using nice emojis, looks a little bit interesting. And though I mentioned not to use the markdown syntax, it still used markdown bold markers here, and also added the link and also build modular microservices effortlessly. So this is the thing we should be careful about. Spring Monolith is not for building microservices. Effectively, it is for building modular monolith. So though it is helping us to generate some interesting content, don't blindly take it and then post it. You should always take this and then tweak it to do the fact check and then correct if it is makes sense or not, and then you can post it. So you get the point, right? You can generate some content and make sure you validate it and then correct it if it is not really reflecting the correctness, and it is already helping with some nice hashtags, and I would say it is helpful. And this is how you can leverage various prompt techniques by using external files. You can define not only for system prompt, you can also use it for user messages as well. And you can use this prompt template if there is only certain parameters that change. And this is how you can specify how the LLM you should tell LLM that this is how you should behave. So this is about prompt templates. And also, if you take a look at the official documentation in prompts section, there is a subsection called creating effective prompts. This is really important because this is how we essentially interact with the LLMs. So we should know how to effectively write the prompts. So here saying that instructions offer clear and direct instructions to the AI. So as I mentioned many times in my videos, think of it like a junior developer, and the more clear instructions you give, the better the chances that you may get what you are expecting. And also external context. So if you are asking the LLMs to do something for you, and if it does not have all the context, obviously it is not able to generate the more accurate content. So for whatever the topic you are asking, what are the task you are giving, if it needs some external context, find a way to pass that external context, either embedding that external information as part of the input itself, or making tool call APIs, or things like that. User input, this is what essentially we ask the LLM. And finally, output indicator. So this is a very important point. Like, so far what we have seen, we ask LLM some question or task, and it returns some textual response. What if we want the response to be in JSON format? What if we are expecting that JSON format should follow certain fields like, okay, title, content, tags, or something like that? So that is where you need to specify what is the format you are expecting, and inside that JSON, what is the fields you are expecting, so you can be more clear about what is the expected response. So by providing all these things, you have a better chance of getting the expected outcome. So this is about prompt templates, and I hope you find this useful. So in the next video, we are going to talk about the structured outputs. Welcome back. In this episode, we are going to learn about structured outputs. So far, we have built an application using Spring AI where we interact with LLMs by prompting and then getting the response as a text, probably as Markdown. But that is sufficient for, let's say, if we are building a chatbot application where user asks LLM something and then it returns some textual response where user can read it. That could suffice the use case. But what if we are building an application where our application is going to ask LLM for some information, and once the LLM returns the response, it needs to act upon that data. Let's say we are asking for some address. And if the LLM returns the response as a text, and if we need to parse the text to identify which part is the country name, which part is the zip code, which is the post phone number, that would be really difficult because a zip code might look similar to some other number. We don't know exactly which is what. So this is where structured outputs come into picture, where when we ask LLM, we also say, I want you to give the response in this defined structure. So LLM will understand that, and it will follow that structure that is expected from the users and try to return the response in that format. So let us see how we can achieve that by using some examples. I have created another module for structured outputs. So here I took the same code from the previous module, but then refactored the chat controller to return the response in a structured format way. So in the previous episode, we have seen if we are asking LLMs to give some title suggestions for a specific topic, and we also wanted to return a n number of title suggestions, and we use this prompt template earlier. But in the previous episodes, we have seen how we can ask this prompt, and then we get the text response, likely in a markdown format. But I want to return a response in a record like this, title sessions response, and here I am returning all the titles as a list of strings. So here, instead of asking LLM in a plain format, we can say So usually this is at the end of the prompt, we can specify this format placeholder, and then we need to specify which format we want to return the response. So here we specified the format token here, and we have used a list output converter, and while passing the variables in addition to the topic and also the count, we also need to specify what format we want to return. We can take the format name as output converter dot get format. So similar to list output converter, there is a map output converter and also bean output converter. So in this case, let's first understand how this works. So here it is going to specify what is the format we are asking the LLM to return the response in, and then rest of the thing is same. But the key part is once we got the response as a text, we are taking this output converter dot convert and response, because we are assuming that this response is going to be in a format that can be converted into a list of strings because we asked for it. And once we got the response, and then we are using this to convert to whatever the type we want, and then we are constructing these title sessions of response. So let us invoke this API endpoint. I have already started the application, and here I am going to fire this API call and asking the topic for springboot tips and tricks and count, let's say 5. And I'm going to trigger this API endpoint. Now the expected outcome is a JSON format with a titles field containing 5 elements of sessions. Let's see how the response would look like. So here you can see the response is in JSON format, and it is giving these titles. And so now imagine from our application, we don't need to parse anything by ourselves because we are already getting it as a typed data, like list of strings. Now let us understand how this actually works behind the scenes. We have already enabled the logging advisor, so we can see what actual prompt is being sent to the LLMs and what is the response we are getting. So here, if we take a look at the prompt, this is what we are asking for. I would like to give a presentation about the following and specifying the topic, and give me count title sessions for this topic. Make sure the title is relevant to the topic, and it should be a single short sentence. That is the actual prompt we are sending. And also at the end, we are including this format placeholder. But if we take a look at the logs, we can see actually what prompt is being sent to the LLM. So here we can see this is the request that is being sent to the LLM. I would like to give a presentation about the following, and it replace the title and count and make sure the title is relevant to the topic. So whatever we have included up to this point, but instead of in the place of format, here you can see Spring AI replaced that with respond with only a list of comma separated values without any leading or trailing text. Example format foo bar bars. So Spring AI is taking care of adding this additional information to explicitly say what is the format that we are expecting. So we are not including all this, but technically we can include this here right away and then do that. But Spring AI is doing it for us, making it simpler. But this is only one use case. Similarly, we can also expect the response as a map as well. For example, let's say we want to get all the popular programming language names along with their inception years, in which year the language is created. So here the prompt is return all the popular programming languages and their inception year, and then we are saying format, similar to the earlier prompt. But here this time we are using map output converter. Earlier we have used list output converter, because here we are expecting the format like programming language as the key and the inception year number as the value. And we are saying there is no input and directly we are specifying the format to be output converter.get format. And then we make a call to the LLM, and once we get the response, we are converting that text response into JSON, and here we are getting it as a map of a string comma object, and we are returning that map as the response. Now let's go ahead and fire this request here. So as you can see, we got the response as C# 2000, Java 1995. So you can see the response we got. Let us see what Spring AI is sending as part of the format this time. So here you can see request is written all the popular programming languages and their inception here. And in the place of format, when we are using map, it is saying your response should be in JSON format. The data structure for the JSON should match this Java class, Java util hash map. Do not include any explanations, only provide the RFC 8259 compliant JSON response following this format without deviation. Remove the quotation JSON markdown surrounding the output, including the trailing code block remarkers. So here, when we are asking for a specific format, Spring AI is taking care of including the relevant explicit request, saying that how exactly the format should be in. So behind the scenes, Spring AI is doing all this for us. Now let us take another example. So far we have seen a list output converter and then map output converter. But what if we want to get the data in a Java object format? For example, here in the previous episode, we have seen we ask for generating a tweet and then we get it as a text. But we want to get it as a bean, like in this case, a record. I want the actual content of the tweet as a string. But I want the hashtags to be as a separate list of string object. So here, this is the response I want, and this time I'm going to use bean output converter. So here I am saying bean output converter of what is the type I want the response to be of. Like once I created this, and same again we send the format, and the format is once we get by calling the get format, and once we get the response, again we use bean output converter, convert of the response, and it is converting that JSON response into tweet object. So this is how it is. And now let us trigger this endpoint. Now let us see how Spring AI is specifying to return the response in certain object format. So here, if you see, we get the response in JSON format, and it is in line with tweet object, where we have a content and then list of hashtags. So we get the response properly. But the interesting part is how it formulated the prompt. So if we take a look at the prompt, so this is all the system prompt, and let us see. This is our actual prompt, generate a tweet for the following content, blah, blah, blah. And this is where Spring AI does its magic of specifying the format. It needs the response. So your response should be in JSON format. Do not include any explanations, only provide. So this looks similar to earlier. Do not include any markdown code blocks, remove the JSON markdown formats. But this is where it is specifying a JSON schema according to which the LLM should send the response. Here you can see this is a JSON schema specifying the type is of type object, and it should have the properties of type content, which is of type string, and then there is a hashtag property which is of type array. Each item is of type string. So additional properties false. So this is all the magic that is happening behind the scenes, so that we can simply from our application say, return me the response that should look like a tweet object. So behind the scenes, it is all happening. So that is how Spring AI is making it easier to interact with the LLM and then extracting the data and giving us a data in the format of or type or safe objects. So this is how you can use structured outputs to get the data in the format that we decide. So I hope it is clear, and if you are building an application and you want to get the response in a certain way, this is how you can specify structured outputs and then get the response. Welcome back. In this episode, we are going to learn about the concept of chat memory, which is a very important concept while building a AI-powered application. So basically, LLMs are stateless, which means they don't remember or carry on the previous conversational context. So if you share some information about yourself in one interaction, and then immediately if you ask for the same information, they don't remember it by default. But usually while building any chatbot kind of applications, you do expect the AI to retain that context and provide the meaningful responses for the further questions. So this is where chat memory concept comes in, where this is a mechanism where we can provide that extra context from the previous conversation we are having, and then LLMs can take that context into account and then provide you the proper response. So let's see how we can implement this concept in our Spring AI application. And also Spring AI out of the box provides some chat memory repositories where all the chat history retains. So let's see how we can implement chat memory in our application. I have created a new module called chat memory, and again this is same functionality that you have already seen many times. So in this module we are using Ollama, and in application properties we have configured the base URL and which model we want to interact with and all the parameters. And we have one chat controller, and again, we have one API endpoint where we are passing some input prompt, and we are calling LLM by passing the same prompt, whatever we are passing. And then once we get the response, we are returning that as the output, which contains content. So plain straightforward. And also we have already talked about this advisor, where we are setting this as a default advisor, simple logger advisor as a default advisor, so that every interaction we have with this chat client instance, it is going to log the request, and once we get the response, it's going to log the response. So we can see all the details about what is being sent to LLM and what info we get from the LLMs also. So very helpful for debugging or understanding what's going on behind the scenes. So now that we have all this configuration, in addition to that, I have added one more thing to this application, to this module. I have added this timeleaf support, and also added this index.html. So basically this is nothing but a simple chart UI where user can enter some prompt and then submit. Once the user submits it, we are making a call to this API chart endpoint, and then we are passing whatever the user input, and once we get the response, we are adding a message to this chart UI. So let's start the application, and let's interact with the LLM from UI. So here, this is the UI we have. Now first, let me tell, hi, my name is Siva. So here, this is my first message, and then LLM respond with, hello Siva, how can I help you today? And then let me ask, what is my name? I'm not sure what your name is. Could you let me know? Here you can see each conversation, like here, this is one conversation. Hi, my name is Siva. I send it to LLM, and this is the response I got. And then in the next conversation, I asked what is my name, and LLM respond with, I am not sure, because each of this conversation is completely independent. they do not have any conversation history maintained. So it is not able to remember the previous conversation, and it cannot answer what my name is. So this is where chat memory concept comes in, and we usually want our chatbots to remember certain, at least to some extent, remember the previous conversation history so that it can respond in a meaningful manner. So something like this. If I say immediately I gave some information and then I ask the same information, it is not able to tell the same details. But we do expect chatbots to remember that conversation, right? So let's implement that conversational history using chat memory concept. Now, let me go back to the chat controller here. And for chat memory, Spring AI already auto-configured a chat memory implementation using the defaults. So we can add this chat memory. Once we have this, and we can add it as a default advisor so that for all the conversation that I'm having with LLM by using this chatline instance, it is going to automatically add this advisor. Okay, so here, once we have this chat memory instance, we are adding this message chat memory advisor dot builder and take this chat memory instance and build. So we are adding this also as another advisor in this chain as a default advisor. So this memory chart message chat memory advisor, what it will do, every time when we are having a conversation with LLM, in addition to the current message, it is going to take the last n number of messages and also include them so that it will have this previous conversation history, and then it will take a look at all of those messages and be able to respond in a meaningful manner. And by default, it is going to have 20 messages in a window. And if you are having more conversations, it is going to delete the previous conversations. So that is the default behavior. And currently, the chat memory is an interface, and it has this message chat window memory implementation. This is what is already auto configured. And as you can see here, we have max messages as 20. So this is the default one. If you want something else, you can also configure your own chat memory implementation. In addition to that, here if you take a look at chat memory repository, so again, this is an interface with few methods, and we have an in-memory chat memory repository. So all the messages are stored in this concurrent hash map. Okay, so these are the background things that are auto-configured by Spring AI. Now, once we have injected this chat memory and added this message chat memory advisor as a default advisor, now we are going to have the same conversation, but this time let us see the difference. So let me restart. And let's start with, hi, my name is Siva. What is my name? Your name is Siva. So now it is able to remember the previous conversation and then respond with the proper answer. But how it is able to remember the previous conversation? Now let us take a look at the request and response. So in the last response, so this is the request we are sending. So now if I take this complete request and let me paste it in a different window. So here, okay. So this is the request, the second request. That means when I sent what is my name, the second request, it not only sent the final what is my name user message, but also added the previous interactions with the LLMs. So here previously I have asked, I interacted with saying, hi, my name is Siva. And then LLM responded with, nice to meet you. How can I help you today? And then now I am asking this new question. So previous conversations are added as part of the request itself. So that LLM is taking all this context into his consideration and then responded because it has this information. It is able to say what my name is. So all this is automatically happening because of the advisor. So we have configured the message chat memory advisor. So right now we only have 2 or 3 messages only, but it is going to by default, as we have seen, it is going to retain the 20 messages in a window. So that is going to automatically take care of maintaining the context. But again, uh, let's say you said something, you pass some information about yourself or something else, and then you have other conversation like 25 conversations, and then if you ask the same information, it may not remember because that has been removed from the context. Like it can only hold 20 by default, right? So based on the kind of application you are building, you need to adjust the parameter how long you want LLM to remember the previous conversations and all that. Okay, so that is how you can simply configure the message chat memory advisor, and it is going to take care of passing the previous conversations and have the context. So this is how you can configure. But so far, this is using in-memory advisor, which means if you stop the application, all that context is gone. It doesn't remember anything. All the info is there in memory. And as soon as you stop the application, all that context is gone. But if you, of course, if you are building a production grade application, you would like to keep that interactions probably in a persistent medium. So this is where there are other options available in addition to in-memory chart. So we have this, right, chart memory repository, and currently it is using in-memory chart memory repository. But we can store the messages in JDBC, any database, or you can also use Cassandra or something like that. So let's see how we can configure a database to store all this chart history. Okay. I have added this Spring Boot Docker Compose support. I would like to store the messages in PostgreSQL, and I want to use Docker Compose support for interacting with the PostgreSQL database. So I have added this dependency and also created in the project module root. I have created this compose file and configured the PostgreSQL database. And then if I take a look at this, I have added this PostgreSQL JDBC driver as well. And I have added this Spring AI starter model chart memory repository JDBC. So I am going to use JDBC support to store the chart history in the database. And in this case, we are going to interact with PostgreSQL. So this is the configuration. In addition to that, I have also configured this property, Spring AI chart memory repository JDBC initialize schema always by default. It depends on the database you are using. If you are using in-memory H2 database, it will automatically create those tables. Otherwise, you need to either explicitly create those tables. But here I am using always option. That means it is going to create the table if it is not already exist. So the table creation script is already comes a part of this dependency. So you don't need to write that by yourself. So here I just enable that table creation. So with this configuration, if I restart the application, it is going to spin up a Docker container, and let's see here. I'm going to see this Spring AI chart memory table. There is a table created. Right now, there is no data in it. But if I go to here, let's start with, hi, my name is Siva. So here I sent a message, and if you come here and see, by default the conversation ID, by default it uses default and it stores this information, and this is of type user message. And then once we got the response here, that information is also stored. Again, this time it is coming from the assistant, so the type is assistant. So like that, all the conversation that we are having with, let's say I'm asking what is my name. Again, this is going to store in this table. So this uh, information will be captured in the persistence medium, like in our case PostgreSQL. You can also use different types of databases, but in this case we have configured our PostgreSQL to store all this information. So this is as simple as it, but all is good. But right now we are assuming that only one person is interacting, but how we can make different people maintain different conversation. For example, if it is a web application and we build some chatbot kind of application, multiple users parallelly can interact with the LLM. But how do we differentiate which message belongs to which conversation? Right now, we do not provide any specific conversation ID support. So all of the messages are tied with default conversation ID. Of course, this is not going to work if you are building a multi-user based application, right? So now let us see how we can implement these conversations support so that multiple users can interact with the LLM and still keep their conversations separate, isolated. So let's see how we can implement that. So here I have updated the logic in this API endpoint where in addition to the input which contains the prompt, I am also binding a cookie value with this name. So xconv ID, conversation ID, required false, it may not exist. And what I'm doing, if it is null, I am generating a random UU ID as a conversation ID. And then I am making a call to LLM, but also I am adding this advisors. Here I am specifying this conversation ID is nothing but this one. So if we have already a conversation established and it is going to send it as a cookie, we are going to take that value and then make this new interaction also part of the same conversation. Otherwise, if it is null, which means we are starting a new conversation. In that case, we are creating a brand new UUID and we are setting the conversation ID to that new conversation ID. And then again, we are getting the response, and while sending the response to client, we are also creating a cookie with the same conversation ID and set it as to max path and all that. And while rendering the returning the response, we are also using this HTTP headers set cookie to set this cookie value and sending the response. So basically with this one, let's go to our UI, and here let's open this. In the application tab under cookies, let's say we don't have, let's clear it. Okay, so here we don't have any cookies right now. So I'm going to start the conversation first. Hi, my name is Siva. So when I started, it is, let's refresh. Once we get the response, it will set the conversation ID. So here you can see the cookie xconv ID, and this is generated. The last is F73. Now, if we go to our database and check, so we have this F73. These two are from this conversation. Now let's say what is most popular Java testing library? Let's ask something. Okay, so I asked some question and it should be part of the same conversation. So here it already stored with the same conversation ID. But now if let's say I started another browser, here I started Firefox browser, and imagine I'm a different client. Now let me ask what is the popular ORM library in Java. So here, this is my first conversation. So it is supposed to start a new conversation. So here, it is a different one. Here, 723. And if you take a look at the cookies and all, you can see this belongs to the conversation from Firefox. And all these conversations are from Chrome. So this is how you can keep track of conversations per user basis for different conversations. So you can also implement your own chat memory implementation. If you want to capture more information instead of using the default one, you can also implement your own thing. So this is how you can implement a chatbot that retains the previous conversations and then provide meaningful information. So I hope you got the understanding of why we need chat memory concept and how to implement that by using memory message chat memory advisor. So this is how you can implement a chat memory concept. And as we have seen, we can also support different chat conversations with a different unique ID. Welcome back. In this episode, we are going to learn about RAG, Retrieval Augmented Generation. So far, we have seen how we can interact with the LLMs and ask questions and get the answers based on what LLMs already trained on. But what if we want to use our own private data with LLMs? So obviously they haven't trained on our private data and they cannot answer the questions regarding our own data. So this is where one of the technique is using this RAG. So let's understand what RAG is. And before understanding RAG, we need to understand some concepts like what is embedding, what are these embedding models, and what is these vector stores. So before understanding RAG, we need to understand few concepts. So first, let's get started with those concepts. So first of all, these LLM models that we have used so far, they have trained on large amounts of data that is already available on internet. But some data, like our private company's data, might not be available, and obviously they don't know that data, and we cannot ask questions regarding that piece of data. So how do we let these LLMs know about this so that we can interact in a natural language? So we need to some way feed that data into LLMs or provide as some context so that they can understand and then respond in a meaningful way. But we may have a large amount of data, and how do we feed all that data? And also it is not like a textual search like earlier. We have technologies like solar elastic search where we can feed the data and we can search, but it is like a text based search where what are the query that you are asking that needs to match with the data that we have already stored. But this LLMs, we want to search based on the meaning, not the exact comparison of text. So for example, if I say I like XYZ actors, and when I ask who are my favorite actors, it should understand that okay, these are my favorite actors, and you need to answer in the right way. But those two texts may not match with each other. In the input, I mentioned these are the actors I like, but in the query, I might ask who are my favorite actors. They are not overlapping. They are different, but the meaning is same. So in these embeddings, what they call embeddings, this is to capture the meaning of the words. Like when we have some data and we want to feed it, so there are these models called embedding models, which can take these text or images or other data and convert them into array of floating points that represents the meaning of the data, not simply the textual representation. So once we convert the data into these embeddings, we call these embeddings or vectors, and we need to store them in a persistence medium. Like the way we store relational data in SQL databases, we can store these embedding models into vector databases. Okay, once we store the data by converting them into vectors or embeddings, we store them into vector stores. Then what we can do, we can query the data, and it is like a similarity search. It is not like a text-based comparison and then getting the data. It is like a similarity search. So as I mentioned in the previous example, it need not match with the exact wordings or anything like that, but it depends on the meaning. So you can store the data in vector stores, and then you can query the data using natural language, which might not have the exact words matching. So that is the process. Now, coming to all this, how it all fits into RAG, what we can do, like let's say we want to generate some report, but we don't have the data required for that report in LLM knowledge base. Then what we can do, we can read the data source and then convert them into embeddings and store them in a vector database. And when we ask LLMs, before that, first, whatever the user asks for, let's say I want to get the sales report for March 2025. Okay, first I go and query for that relevant data from vector stores, and I take that data and I give it to LLMs as an input and ask generate the report. LLM has the data, required data in the input prompt itself, so it is able to generate the report in whichever the desired format, maybe a markdown format or some other tabular format, something like that. So this is the whole process of RAG, where we are extending the capabilities of LLMs by feeding our own knowledge base as part of the input itself. So this is the theory part of how all this RAG works. Now let's get into the code and see how we can do this. I have created another module, RAG vector store, and if you take a look at the POM file, we have Ollama, but you can use other models as well. But for this example, we are using Ollama. And one thing to remember, so far we have seen chart models. So we have used GPT-5 or Anthropic or Ollama models like Llama or something like that. So these are all chart models where we can interact with the LLMs by asking questions or whatnot. But there are other models like embedding models, image models, audio models. Obviously, looking at the names, we can understand that if you want to work with audio, like you give a audio file and then you want to generate a transcription of it, you can use audio models. Similarly, you can use image models either to generate a brand new image, or you can understand what is there in that image. So you use image models for those tasks. Similarly, we can use these embedding models where we can feed some data, maybe a text data or an image or something like that, or even a video, and then we can generate floating point numbers called vectors. So these are the models we need to use for this task. So looking at this Spring AI documentation here, you can let's take a look at a few of the important points. Embeddings work by converting text, image, and video into array of floating point numbers called vectors. These vectors are designed to capture the meaning of the text, images, and videos. So it is capturing the meaning of the text by mapping those data points into some floating point numbers. Okay, so now in order to work with this RAG and doing this generating the embeddings and all, we need to use the model that supports embedding models. So if you are using OpenAI, it already supports embeddings. But if you are using, let's say, Ollama, we need to pick a model. For example, if I go to Ollama models, I can see here some models support tools thinking, and some models support embeddings. If you click on this, you can see what are the models that support embedding feature. Okay, so you can pick one of the model here and we can use that. For example, I have configured here I'm using Ollama, and for the chat I configured the Qwen 3 model, but for embeddings, I configured this nomic embed text v1.5. So this is the model I have pulled and I configured this. So if I am using OpenAI, I can configure, okay, this is the default embedding model that is used by Spring AI. But if you want to configure other models, these are other options that are available. You can configure them as well. But for this demonstration, I'm going to use Ollama with this configuration. So now we have the configuration and everything ready. Now how we can go about implementing the RAG. So first let us take some configuration here. So I have created a AI config, which is nothing but a springboot configuration class. And here I am binding these two resources that are pointing to this class path markdown files. Here in this resources data, I have two markdown files. One is about Siva, myself. And here I just have some profile details about myself, my name and what skills I have, and where did I talk about where I gave some talks, and how to reach me, like my email, blog, YouTube, so etc. All the social media contacts. So this is basically about my profile details. And this is something I have a blog post, few things I learned the hard way in 15 years of my career. So basically this is a blog post written in Markdown. So I have these two files now. And what I am going to do, once I have these two files bind to these resources, and I have configured a bean called vector store. So as I described earlier, once we convert the text into embeddings, we need to store in a database. In this case, we are going to use vector stores. As I mentioned, for storing the relational data, how we use SQL databases. Similarly, for storing these embeddings, we need a vector store. So there are a lot of vector stores available, and out of the box, Spring AI provides this simple vector store. You don't need to download or run anything. This just in-memory implementation. So this is good enough for learning purpose, but for production, obviously you need to use something more reliable. So here, let's go with this simple first, and then later we see how we can use a different vector store. So once you add this embedding support, you will get this embedding model auto configured, and you can create this vector store bean like this simple vector store dot build, and you take this embedding model and you create this bean. Okay. Now, once I start the application, automatically I would like to pass these files and generate the embeddings and store into this vector store. So for that, I am configuring this application runner bin, which is going to automatically execute once I start the application. So here I am injecting this vector store, and I am trying to load these two documents into this vector store. So this is nothing but another private method here. And based on the type of document you are trying to load, you can use different document readers. So Spring AI already provides document reader, writers, and all that. So here in this case, if you want to read some text file, you can go use this text reader. If you are trying to read from PDF files, you can use this PDF document reader. And if you are reading from some MS Office documents, PPTs, and all that, you can go for TCAR document reader. So basically, you can add these starters from Spring Initializer itself. So here you can see there are dedicated document readers for different formats, for Markdown, for PDFs, and for other various types of formats. So based on your type of data, you can add these starters. So I have already added them. If you go here, you can see Markdown document reader, PDF document reader, TCAR document reader. We already added these three things. So once, because I have these Markdown files, I have created a Markdown document reader, and by specifying what are the resource I am passing, and then we are passing this default configuration. And Once we have a document reader, we can simply call the get method, which is going to return a list of documents. Again, this document is a type provided by Spring AI itself. So it is going to take care of parsing the document and then preparing this list of documents. Sometimes these documents may be large documents and you may want to split them before converting them into embeddings. So this is where you can use a text splitter and you can pass those documents, which is going to further split into more documents. And once you have all the documents, you can simply call this accept method and pass these documents, which is going to take care of internally generating the embeddings and then finally store into these vector databases. So we are automatically on the application startup itself, we are taking these two files and then generating the embeddings and storing into this vector store. Okay, now that we have the data in our vector store, how we can query them? Okay, so now let us take a look at this chart controller. And before talking about search, here are a couple of things that we can understand. I already mentioned, okay, we can generate the embeddings and all that, right? So here is some example that you can take a look at. Let's say we have this text and we want to generate embeddings. So we have embedding model configured by Spring AI. We can simply call embed and pass this text, which is going to return this embeddings, which are nothing but floating point arrays. This is how you can simply convert a piece of text into embeddings. Or if you have a list of strings, you can also pass the list of strings and then you get a list of floating point arrays as well. Or we have seen the document, right? That is nothing but we can pass some data and also pass some metadata. This is nothing but metadata. Here I am saying the source is from some uploaded documents. So you have a document. Now you can again pass the document to embed method, which is going to generate a floating point array. So these are all different. Otherwise, you can also create a embedding request by passing a list of strings, and you can pass even options. And then you can call the embedding model.call, pass the embedding request and generate the response, which is again nothing but containing all the list of floating point arrays. So basically, this is nothing but you input data. In this case, it's just a text, but you can also pass the media like images and all, and you get the floating point arrays. Finally, once you have the floating point arrays, you can store them into vector stores. Okay, let's say once we have all that data in our vector store, this is how you can query the data. Let's say this is another API endpoint we are using here, and we ask for some question and we can say similarity search and pass the whatever the query that we are asking for. So what it will do, it will search for the similarity in terms of meaning in the vector store and then return the documents that matches with this query. And once we have the documents, in this case, we just want to club all of them into a text and then return it. So earlier we have seen, we have loaded these two documents, right, about Siva and this one, and we have already stored that into vector database, and we have this API endpoint. Now let us see how it works. So let me start the application. So here I have a API endpoint. I'm trying to invoke this API search endpoint, and here I am asking how to contact Siva. So if you take a look at the text here, how to reach Siva, or we can even make it different, but it is kind of a meaning, from the meaning point of view, they are kind of a similar, right? So let's see how what kind of response we are going to get if I ask how to contact Siva. So let me trigger this API endpoint. So here you can see it is returning the document from that markdown file that contains all the details here. Okay, so here you can see this is nothing but all the data that is there inside this file. Okay, so that is how you can query the data from vector store by using this similarity. We can pass more filter techniques and all that, but basically this is the concept. This API endpoint I have created just to see how we can behind the scenes use vector stores for querying relevant data. But our main question would be, we have this chart API endpoint where we can ask some question, and we want to uh, ask some question about the data we have ingested already. Okay, but here if I ask, okay, how to contact Siva through this API endpoint, here we are asking LLMs, right? But we just stored the data in a vector store. But how LLM is going to use the data that is there in a vector store? This is where we are going to add this advisor, question answer advisor, builder, vector store, and builder. So earlier we have seen how we can use this message chart memory advisor to automatically add the previous conversation. Similarly, there is this question and question answer advisor, which is going to take care of first query the vector store, get the relevant data, and append to the prompt that user is already asked. So for that, let us do one thing. If we go into this question answer advisor, here you can see a prompt template where a query, which is nothing but the query that is asked by the actual user, and then we have this context information is below surrounded by these markers. So this is where the relevant data that we pulled from vector store is going to be placed, and then we are saying given the context and provide history information blah blah blah, only answer based on this context. Okay, so this is how internally it is going to work. For that, let us also take a look at, okay, so here I'm going to put a breakpoint, and in this augmented user text we can see effectively what prompt we are sending to the LLM. So I put a breakpoint here. Let us see what value it is going to have in this. So here I'm making a call to API chart endpoint, and I'm asking how to contact Siva. So here let's trigger this API, and here we got the breakpoint. And if you take a look at this augmented text, so let's view this. So this is the query I have asked. This is the prompt I asked, but behind the scenes this question answer advisor take care of asking querying the vector store, and then got the relevant data. So here you can see it got all this data from vector store appended to the prompt, and then we are sending that as a prompt to the LLM. So now let it go, and now see what kind of a response we are going to get. So here you can see the response. Okay, the user is asking how to contact Siva. Let me check the context provider. Looking at the context, there is email listed as SivaLabs.in.com. Also, there are links to his blog, YouTube, LinkedIn, GitHub, all this. See all those contacts point. So here we have all the data that is written. Let's try this from UI itself and see how. So in the previous episode, we have built this nice UI, and let me ask this question from UI and see how it is going to respond. So here you can see it got the data, it returned all the details for myself. So here you can understand that we are not only able to interact with the LLMs based on what it already knows. Here we are able to feed the data, our own data, and then we are able to interact with using natural language. So we are essentially extending the capabilities of these LLMs by using this RAG technique. So now we have seen how we can use this default simple vector store that is good enough for POCs and for learning purposes, but obviously we should use something more stable and persistence medium to persist all this data, right? So now let us see If we take a look at the Spring AI documentation, there are a lot of databases that supports vector storing. So here you can see there are a lot of options, but let's see how we can use Redis. Redis we can use as a vector database. Let us see how we can configure Redis and use for RAG. As I mentioned, I would like to use Redis as a vector database. So here I can go ahead and search for Redis. Here you can see Redis search and a query vector database. So I can add this. And also I would like to use Docker Compose support for spinning up this Redis instance. So if I select that, if I explore, you can see some dependencies added. Here you can see Spring AI starter vector store Redis. This is the dependency that needs to be added. And also here we have both our Springboot Docker Compose support, that is for generic Docker Compose support for any databases and things like that. So here there is one more module that is tailored for AI components. So here we have Spring AI, Springboot Docker Compose. So these are the dependencies we need, and I have already added them in our POM file. So here we have vector store Redis and Docker Compose, both of them. And also while generating this, it is going to generate this compose YAML file, and it use Redis tag as the Redis database. Because it's a different instance, we need to specify this label so that service connection feature automatically works. So we already have that in compose.yaml file. I changed the version from latest to this specific version. This is always a good practice to use a specific version instead of latest. And finally, we need to configure to initialize the schema. So as I mentioned, Spring AI supports a wide range of vector databases, including there is a Postgres variation also, PG vector. So in order to store this data, we need to have some database type, right? We need to initialize it. So most of the supporting databases also allows you to automatically initialize the schema, and we can simply enable it by configuring this property. So now that we have everything, we can simply comment the previous simple vector store bean configuration. We don't need it anymore because we have added this startup, which automatically going to configure a vector store, which is nothing but backed by Redis vector store. We can even check that. Let's say put a breakpoint here, and when we start the application, we should see what type of a vector store we have here. Let me restart. So here you can see the vector store is a Redis vector store. So everything is configured using Redis now. Let me proceed. Now we can ask the same question, like let's go back and uh, give me Siva's social media contacts. Let's see whether it is able to query the Redis vector database and pull my data and give the contact details. Yes, so here you can see details and then my social media contact details here. So that is how you can leverage one of the supporting vector databases for implementing RAG. And this is a kind of a very powerful technique. RAG is one of the approach where you can add your personal data, private data as a context, and then you will be able to interact with through LLMs using natural language prompts. So I hope you understand the concept of RAG and how to implement it with practical examples here. I hope you understand how to leverage the technique of RAG for extending the capabilities of LLMs. Welcome back. In this episode, we are going to talk about the tool calling capability. So basically, what we have seen so far is we interact with the LLMs and we may ask some questions and it will return based on what it has already know about, like based on the training data. And in the previous episode, we have already seen how we can extend the capabilities of LLMs by using the techniques like RAG, where let's say you have your own knowledge base, your company's private data or whatnot, and probably it's in the documents format or in database, wherever. So you can store all the data in a vector store, and when somebody asks for information, first you perform the similarity search and take the relevant information and provide as part of the prompt to the LLMs. And based on the context provided, LLMs can return the more accurate results. However, there are certain limitations like what if the data you are asking is very real-time data where it keeps changing every second or something like that. Also, what if you want to actually take an action? For example, I want to create an event in my calendar. But so far we have seen most likely it is like getting the information from LLMs but not taking any action. But what if we want to build a AI powered application where we want to take certain actions like creating an event or sending an email? So how do we do that? This is where tool calling comes into picture. So in this episode, we are going to look at how we can implement that so that we can not only provide the real-time data and also we can take certain actions by using tool calling facility. Let's get started. I have created another module for tool calling feature. So in this module, we are using Ollama. And here I have configured the Ollama base URL. And regarding the model, we need to pick the model that supports tool calling capability. So if we go to Ollama, here go to models. Here you can filter the models based on the feature. Like I want to use some model that supports tool calling. So here GPT OSS supports it, Qwen3 also supports it. So I'm using this Qwen3 model here. I have already pulled it and I'm configuring that to use for this sample. So here we are, imagine we are building a simple help desk application where it needs to provide assistance for the help desk, front desk people to know who are all the employees on leave on a given date or maybe today or maybe apply for a leave. So those kind of a capabilities. Again, this is specific to particular company's data and obviously out of the box LLMs can't do that. So this is where we are going to provide the tools that can do these tasks. For example, if let's say somebody asked, okay, who are all the employees on leave today? So LLMs don't know what is the today because it has a knowledge cutoff time and it actually doesn't know what is today's date. So first we need to provide a tool that knows what is the current date. And then once it figures out the date, it needs to call some tool that fetches the data like, okay, who are all the employees on leave for the given date. So something like that. So basically we need to provide all these tools, make available them to this LLM model so that when we ask any question to the LLMs, it knows, okay, I have all these tools available with me, and based on the need, it calls those tools and then get the additional context or take a necessary action. So we are going to implement something like that, and by that we'll get to know what a tool is and how we can leverage them. So here again, I have a simple application and we have a simple chart controller, and I am setting this default system prompt. You are a helpful assistant for SivaLabs company. Imagine there is a SivaLabs company and there are employees in it. And let's say the front desk people want to ask questions like, okay, who are all on leave today or a given date or apply leave for some person. So something like that. So I configured that. And here is something we need to be a little bit more specific, because if you don't say like, okay, if you always respond based on the data you have from the tools available to you, if you don't know the answer, you will respond with I don't know, so that it doesn't make up hallucinated answers and all that. So we are specifying a default system prompt like this. Now let's get into how do we provide the tools for the LLMs. So this is a basic example in most of the documentation. As I mentioned, LLMs doesn't know what is the current date because it has the knowledge cutoff time. So we are providing a tool that can figure out what is the current date. So here the important thing is, once we use this add tool annotation to mark this method as a tool, you can provide the name as an optional, but if you don't provide the name property, it will take this method name as the tool name. The most important thing is description. So this is what LLMs see to figure out, should I use this tool to get the necessary information or not. So if I ask LLM what is current today's date, it will see, okay, get the current date in so and so format. So it will figure out, okay, this is the tool that can help me for getting the necessary data. Similarly, let's imagine we are storing the information of employees in a database, and we have some methods, and we want to provide some tools to figure out the employee leaves and all that. So let's say we have an employee class with some properties, employee ID, name and email, and we have this employee service, which is a Spring Bean. Earlier we have this class, this is not a Spring Bean, it's a plain class, and we use this add tool annotation to mark this method as a tool. But here we have a Spring Bean, and instead of storing the data in a database for demonstration purpose, I am storing all the data in a hash map itself. We have a employee table hash map where we store the employee ID as the key, employee object as the value. And also I have another hash map, employee leaves table, where I store the current date, not the current date, whatever the date as a key, and who are all the employees on leave on that date. So these are the two things I am maintaining. And when I start the application, I am initializing some data here. So here I have 3 employees, and I provide their name, employee ID, name and emails. And then I have initialized some sample data in the leaves table as well. So whatever the date, today's date, I mentioned both employee 1 and 3 are on leave, and also I put some older date, 2025 January 1 and 2 on these employees are on the leave. So I initialized the sample data here, and I have few methods like to get a specific employee details and find employees on leave. So when you give a date, we are figuring out who are all the employees on that date. And again, get employees, given employee IDs, it will return. So it's a basic Spring component that fetches the data from the in-memory store. Also, we have this apply leave method, which takes employee ID and date, and we perform the whatever the necessary logic to make this person is also on the leave for the given date, and putting it back into the employees leave table hash map. So basic, nothing complicated here. But the interesting thing is we have another class called employee tools, and we are also making it as a Spring Bean, and then we have injected employee service into this employee tools, and we have exposed few methods as tools for the LLMs. So here, get employee details for a given employee ID of SivaLabs company. And similarly, find employees of SivaLabs company who are on leave for a given date. So for a given date, we will return who are all the employees that are on leave on the given date. Similarly, we have another method for applying leave for the given employee ID and date. So if you notice, we provide the detailed description so that when we ask something, LLMs can take a look at this and then figure out which tool is helpful to perform the necessary action. And once we define these tools, also make a note that our tools can be in non-Spring components like datetime tools, which is not a Spring component. And also we have a Spring component that has tools. Okay. Now, how do we let LLM know about these tools? This is where we are going to register these tools into the chart client. So if we take a look at the chart controller, so here, while constructing this chart client using this builder, we are specifying the default system, and also we are providing the default tools as employee tools. Here we are injecting, because employee tools is a Spring Bean, so we are injecting that. And datetime tools is not a Spring component, so we are simply instantiating a new instance here. So we are creating an object of it and then providing these two things as a default tools. Okay, so this is how we let this chat client know about these tools available in these two components. Okay, once we have this, we can chat with the LLMs, but this chat client already has the context of these tools. Okay, now let us see how we can use those tools and ask various questions that require LLMs to invoke those tools. So here I have an application test. So here basically I am making a call to this API chat endpoint, and I am providing some input, but we have already specified the system prompt here. So now what kind of a questions we can ask? So here I am using this parameterized test for running with different prompts. Instead of writing different tests, I am asking different questions and then using the same as a prompt for each time. Okay, so what we are doing first, what is a today's state? So the expectation is when we ask when we invoke this API endpoint with this prompt, we are expecting the LLM should invoke this method. Okay, and then we should get answer. And similarly, there is another question: get details of employee ID EMP1002 of SivaLabs company. So based on this question, we hope it will check the tools available in this employee tools. And here I mean, the question need not be exactly same as description, but as LLMs can figure out the meaning, similarity meaning, it can be slightly different, but what the meaning should provide the context. Okay, so we have all these tools. Now again, I am asking which SivaLabs employees are on leave on a particular date, and also I am also asking which SivaLabs company employees are on leave on today. So this is an interesting thing, because first it needs to figure out what is a today's date. Again, for this it needs to call the datetime tools and get the current date, and then make another tool call to figure out who are all the employees on leave for that day. So here for this use case, it should call both the datetime tools get current date and also these employee tools one. Okay, so finally we are also asking to apply for leave for a given employee ID on a given date. Okay, so these are all the various use cases, in this case different prompts. Now let's run this test and see how it works. So the first one, let's select this first one. This is what is today's date. So here, if you check in the logs, I have added logs for all the tools so that we can see whether it is actually invoked or not. So here I have logged this get current date, and if you take a look at it, so here you can see datetime tools get current date is invoked for the first one. And for the second one, get details of employee ID 1002. So here we are expecting it to call employee tools. So here it is calling this getting employee so and so. Okay, so if you go here, you can see the log statements from this tool. So this tool is called. And if you take a look at this third prompt, which SivaLabs company employees are on leave for on some given date. Again, for that, we expect it to call this tool. Again, if you take a look at finding employees on leave for date, so and so, and it got the data and then it returned the response. Looking at the response, it takes the data and then provides information in a like textual response. So it got all the response, and then the final response is here. You can see okay, the user asked which SivaLabs employees are on leave on so and so date. I called the find employees on leave function with the date. The response from the tool listed two employees, John Doe and Siva. Now I need to present this information clearly. Let me check if the dates in the response match the query. The date provided was so and so, and the tool's response is valid for the date, so I will format the answer to list both employees with their date. So basically you can see it is giving all the information of how it came up with this response. So these are the two employees that are on leave for the given date. Now, next interesting use case is we are asking which SivaLabs company employees are on leave on today. So this is where we are expecting first it should get the current dates information from the date time tools, right? So let us see that. Here you can see first it called getting current date, and then today's date is 26 August. So it automatically passed that date for employee tools as this date. So it figured out what tools it can use to fulfill the given prompt. Okay, you can also see that explanation in the response. So, okay, let me process this. The user asked which SivaLabs employee are on leave today. I first called the get current date function to get today's date, which returned August 26. Then I've used this find employees on leave function with that date. So you can see all that information, and the following SivaLabs employees are on leave, so on, so date. So like that, you can use the tools that extend the capabilities and provide more real-time data. And also the last one is apply leave for SivaLabs company employee of so-and-so date and so-and-so employee ID. Again, it called this method. Here you can see employee tools, applying leave for employee so-and-so on given date. So basically, the whole point of tool calling is you ask something to do in a natural language, and LLM will figure out which tools can fulfill this request. Maybe not entire operation, but even if it needs one or more tools, it will figure out, okay, first I need to leverage this tool capability to get some information, and then pass that information to some other tool to perform some action. So it will take care of leveraging all these tools for fulfilling the whatever is the request from the user. Okay, and here I just, to make the main point on focus, I just stored all the data in a simple in-memory hash map and do this. But the same thing it is up to you what kind of a logic you implement in these methods. Here you can talk to a database, you can make a call to third-party APIs, and whatever you want to do, you can do that. So the actual logic in these methods are up to us, but the whole point is letting the LLM knows that we have these additional tools available, and based on the question you are asking, it will leverage what are the tools I can use to fulfill the user request. So here we can see we are able to make some actions, like in this case we are applying leave for a given employee, or we can get the data, kind of a real-time data. When we say get the employees on leave today, it will figure out what is today's date and also get the employees leaves data for that date. So that way we can extend LLM's capabilities by providing these additional tools. So combining both the RAG and these tool calling capabilities, Basically, we will be able to build our own AI-powered applications that fulfills our own business needs, not just getting the information from the LLMs. Okay, I hope this clarifies why we should use tool calling and how it extends the LLM's capabilities. Welcome back. This is the last episode in this Spring AI series, and in this episode, we are going to talk about Model Context Protocol. And first, we are going to understand what is this protocol is about and how we can use the existing MCP servers out there already. And we are going to learn how we can build our own MCP server using Spring AI. And also, we are going to build our own MCP client as well. So let's get started. If you go to modelcontextprotocol.io introduction section, here you can see an interesting definition like MCP is an open protocol that standardizes how applications provide context to large language models. Think of MCP like a USB port for AI applications. So just like the way we can use the USB-C type port for connecting any device that is compatible with this USB-C port. So that way, when we are building AI-powered applications, we may have to interact with a wide range of third-party services, be it another REST API, be it talking to a database or file system or Git repository. So we may have to interact with a wide range of other services, and this MCP protocol allows us to build a MCP server, and we can interact with this wide range of tools and technologies using natural language. Like just like the way we have seen so far, like we interact with LLMs using natural language, and then by providing the capabilities like RAG or tool calling, we are extending that capability, right? So this is kind of a one step further and also kind of a standardized approach to extend LLM's capability. So let us take a look at the examples, some scenarios, so that we'll understand what exactly is MCP. So for example, let's say we are building a Java application and we need to interact with the database, and we may need to interact with the third-party REST APIs and all that. So far, before MCP, before all these AI things, how we used to interact with them? Like, let's say we need to interact with this REST API. First, we understand what kind of APIs they expose, and then based on that protocols and REST API request and response formats, we need to code in our application to interact with those APIs. Same thing goes for database. Depending on which language you are using, you may use JDBC or some other thing, and then you interact with that. So it is kind of a tight coupled with the language you are using and what is the service you are interacting with, and is it a REST API, is it a gRPC? So it is a very tightly coupled. And with MCP, what you can do, so let's say somebody built a REST API and also they build a MCP server that handles interaction with this REST API. Now, from any of your application, you can interact with MCP server instead of directly talking to the REST API. You can interact with the MCP server in a natural language, like just like the way we interact with LLMs, right? So similarly, you can interact with the MCP server, and this takes care of doing whatever is necessary. You may want to get some information, or you may want to create a new resource that you can achieve by interacting with the MCP server. And the benefits is this is a standardized protocol, right? So now it doesn't matter whether you are building a Java based application or Python based application or whatever, it doesn't really matter. Same way, whether it is a REST API behind the scenes, or is it a gRPC service, is it a database, you didn't care about that. All you need to do is in your application, you configure to talk to this MCP server, and then it takes care of interacting with the necessary components. So that way you are kind of abstracting what is there under the hood and you will be able to interact with this MCP server in a natural language, which is that is how most of the interaction will happen in the AI powered applications, right? So this is how they are going to help. Let's first understand how we can use MCP servers that are already out there, so that we'll get some understanding of okay, this is the concept and this is how we can interact with use MCP servers. Okay, let's get started. If you go to github.com/model context protocol/servers, here you can see all the available MCP servers that are listed here. This is a huge list, and it seems there is a MCP server for everything that you can imagine. So now we have all these MCP servers, and depending on our need, we can pick which server we want to use. And we need a client to use these MCP servers. So one of the popular MCP client is Claude Desktop. So I have downloaded the Claude Desktop, and once you start it, it looks like this. And if you take a look at how to connect to local MCP servers in this documentation, here, when you use Claude Desktop, and if you want to use MCP servers, there is a configuration file depending on your operating system, which operating system you are using. There is a configuration file which is in JSON format. This is where you are going to configure which MCP server you want to use. Okay, so I'm on Mac OS and I have this configuration file, and in this configuration file, this is how we can configure MCP servers that we want to use. Let's say in this example, there is only one MCP server configured, which is file system, and it specifies a couple of things. One is what is the command we need to use, and what are the arguments that you want to pass. So in this case, this is a file system where you can interact with these folders. You can ask what are the files that are there, or anything like that. Whatever the things you want to do with this file system, you can interact with by configuring this file system. But let's say we have a database. So I have installed a PostgreSQL database, and which is currently running in Docker, but it is exposed on the host as well. Now there are users table, posts table, and comments table. And let's imagine I want to interact with this database to explore, okay, is there any post that on the clean code? Is there any post on the prime phases? Something like that. And of course, we all know how to write SQL and get those things, but let's see how we can use MCP server and interact with this database without having to write SQL. Okay, so let me open. So here I have this Claude Desktop config JSON, and here you can see I have configured a few MCP servers already. This is a very popular, Context 7 is a very popular MCP server that you can use to get up-to-date documentation about the frameworks and technologies and all that. And here is the MCP server that I configured that I would like to interact with the database. So here, if you take a look at this list of servers, okay, and Postgres, currently this is archived, but just I would like to show the process so that it is same whether it is archived or a different process. But here, this is how you can configure talking to database. Like if it is already running in a Docker container, you may want to spin up a Docker container, and from that container, you want to connect to the PostgreSQL. So if that is the case, you can go for this approach. Instead, if you want to use npx, for this you need to have a node installed on your system. So if you have npm installed, you can use this approach where the command is npx, and you can start this process and interact with the PostgreSQL. So in my case, I'm going with this npx approach. So here I configured, I'm going to use npx, and this is the PostgreSQL server, MCP server that I'm planning to use. And this is the URL for my database. So username is Postgres, password is Postgres, it's running on my local host, and the port is 15432 and the database is this. So once I have configured this, and as I have already shown, it has all these posts and everything. Now from my desktop, here I can see what are all the MCP servers configured. Here I have a bunch of them, but here you can see Postgres, right? So there is only one tool exposed from the Postgres, which is query. Now let's ask, are there any posts on Linux in PostgreSQL database? So here, as you can see, I'm not writing SQL, but I am asking in a natural language. And here you can see failed to call tool query. Let's see why it failed. So first, I think it created a request saying that select star from post where title I like Linux and all that. So here there are no tags column in the post table, so it failed. So then it is taking care of first looking up the structure of the post table and look at the columns and all that. Okay, once it has all that information, now it formed a better query that checks for posts on the Linux. Here it got this information and there is only one, so it fetched more information about the that particular post. So as you can see, we are interacting with the database using natural language, and the MCP server is taking care of doing all this behind the scenes, understanding all that, and finally giving the response. Okay, there is this information. So this is how we can interact with database using MCP server. Let me show another example of using MCP server. So here I have this playwright MCP server configured. Again, I am using npx command, and this is the MCP server I want to use. In addition to that, I have configured the output directory to be this my home directory downloads folder. So once I have configured this, there are many use cases for using playwright, but let's say I would like to take a screenshot of my blog. Let's say, okay, what can I do? Take a screenshot of https SivaLabs.in. Okay, so now if I trigger this MCP, this cloud desktop application, which is a client, understand that which tools available to it can perform this action. In this case, there is a playwright tool that can navigate to a specific web page. So here it is asking me for execution permission. So I'm saying allow once, and first it is going to navigate to this URL, and then it is going to invoke another tool called browser take screenshot. So again, it is asking me for the permission. Now when I approved it, it is going to perform that, and it took a screenshot and saved it in SivaLabs screenshot.png file, which is there in my downloads folder. Now here you can see this is the screenshot of my blog. Okay, so this is how you can use MCP servers. And similar to that, I have configured another MCP server like for YouTube. So here what we can do, we can interact with YouTube, and we can ask for a particular video details, or ask what are all the videos available in a particular channel, things like that. Okay, so let us see how we can use this YouTube MCP server. Now let me start a new chart and ask what are the last 10 videos published on channel. So this is my SivaLabs YouTube channel ID. So I'm pasting it, and I'm asking to give me what are the last 10 videos published. So let us see how it is going to perform this action. So earlier I have already approved it, so it is not asking for the confirmation again. So here you can see this is invoked, this tool provided by that YouTube MCP server, and here you can see the last videos I made on Spring AI. So here you can see all the video details that I published, the last 10 videos. So the whole point is, without having these all technical details and all these things, by using this MCP server, I can interact with with this wide range of services, and I can get the data and all that. Okay, so these are all the MCP servers that are already created. Now let us understand how we can create our own MCP server using Spring AI. Okay. Using Spring AI, we can create MCP servers in different ways. One is using STDIO protocol, standard IO, or you can also use Webflux SSE, server-side events, or WebMVC SSE approach as well. But here we are going to see how we can create an MCP server using both STDIO and Webflux SSE based approaches. Okay, so first let's start with this MCP server standard IO approach. And if we take a look at the pom.xml, here we are adding this Spring AI Starter MCP server. When you generate an application from Spring Initializer, you can add this model context protocol server, which is going to add the same starter as well. Okay, so once this starter is added, in this MCP server, we are exposing some information that we are storing in the database, in H2 database. So I have added this data JPA and H2. So let us take a look at the code we have. In a schema.sql file, I have created a single table, and I stored information about the videos and the URLs and things like that. Okay, and we have this video entity again representing this table, and we have video repository with few custom finder methods. Nothing too complex, basic Spring data JPA code here. And the interesting part is we have this video tools component, and here we injected the video repository, and then we have exposed 3 tools. If you remember from the previous video of tool calling, here we are using the same functionality, like we are exposing some tools from our MCP server. So in this case, we have one tool to get all SivaLabs videos, and behind the scenes we are simply querying the video repository find all, and there is a search SivaLabs videos by the title, and again we are using find by title containing ignore case. So just we are doing a like search, ignoring the case sensitivity. And also we have another tool to get one particular video details for the given title. So we have 3 tools exposed from our MCP server, but this is just a video tool as of now, and this is where we are registering the tool callbacks. So we have injected video tools, and then let's refactor this, and we created tool callbacks from so and so component. So if you have more such tools, you can inject them and also pass them in this tool callbacks from method. So this is how we can export a bean of type list of tool callbacks, which is going to internally automatically expose all the tools that are defined here. Okay, so this is all we want to do, but let us take a look at this configuration as well. We are giving some name, and because this is a standard IO based MCP server, this is not a typical web application type, so we are explicitly saying web application type is none. And also we are giving some name version to our MCP server, and also configuring we are going to use standard IO based protocol by setting it to true. And very important thing is to turn off this console logging. typically when you start a Spring Boot application, it will print the banner and also use by default console logger, right? So while using this standard IO based protocol, we should not have any logs or things like that. And basically you should not be using system out.println and also in our code. It is going to interfere with the data exchanged or standard IO. So you should not be logging in this console. And I'm just using DDL auto generation for schema. So nothing too fancy in this one. And once we have application created, now we can go ahead and build this application. I simply call maven clean package and it will create a jar file. Once I have the jar file, here I have the jar file. So what I have done, I have added the MCP server we just created with the name SivaLabs, and I'm using the command. So basically I'm pointing it to Java. I'm using ST command, so I'm pointing it to the current Java, that is default that I set globally. So once we have typically how we run a Spring Boot application, we are doing the same thing here, Java minus jar and complete path to the jar file. Okay, so nothing too complicated here. Once we have configured this, we need to remember this important thing. Whenever you make any changes to this Claude desktop JSON file, we need to restart Claude code. Otherwise, it won't pick the configuration automatically. So let's restart this. And now let's ask details so that it is going to pick data from the SivaLabs MCP server. So basically here we are exposing this information, right? Get all videos from SivaLabs and things like that. So let us search for some videos from SivaLabs. What microservices videos available on SivaLabs? So here it is, it will try to ask, okay, here you can see it is using a SivaLabs MCP server, especially this set SivaLabs videos tool. So I'm allowing it once, and it's go ahead and sets the data that is there in the database itself, because this is what we are doing. We are particularly searching in the database, but this is the thing, whether you want to interact with the database here or you want to make a REST API call to some other API. So you do whatever it takes, but we are exposing these tools as MCP tools. Okay. So here you can see, yes, this is the tutorial based by microservices I have. It shows this information. So as you can see, we created a simple MCP server and we configured that like this, and we can verify that using Claude Desktop as well. In addition to that, we can also use introspector. Let's go ahead. And here in the README, I mentioned model context protocol inspector. There is a tool that we can use for configuring this and then testing this API endpoints, MCP tools. So let's start this. Okay, so here you can see this MCP inspector tool automatically opened in the browser. And let us go back, and here I have mentioned how we can test this. So transport type is standard IO and command is Java. So let's choose standard IO Java, and this is where we need to specify the complete path to our jar file. So here I have already configured that. Now let me click on connect, and here you can see it is connected. If you go to this tools, here click on list tools, you can see these three tools are available from the SivaLabs MCP server. Now let's go ahead and get our videos, run this tool. So here you can see it returned all the information. Okay. So that is how you can also locally verify if you are building your own MCP servers. This is a very handy tool that you can use to connect to it and then test this. So this is how we can build a STDIO based MCP server using Spring AI. Next, let us take a look at building the same MCP server, but this time we are going to use Webflux SSC based protocol instead of standard IO. Okay. So earlier we have added the dependency of Spring AI Starter MCP server, but this time we are going to use Webflux version so that we are going to expose our MCP server via Webflux SSC. Okay. Now this is the only change in terms of dependencies. And if we take a look at properties file, here we are not configuring this as a web application type none because it is going to run as a web application. So we should not configure that. And I am customizing it to run on the port 8181. And also I am giving a different name to my MCP server, and that's it. So rest of the code is exactly same. There is nothing much change. You can use the exact code. But this time we need to run the application in order to connect to it and then invoke the tools, because this is a web application type. So let's go ahead and run. And it will start on port 8181. So let's go ahead. So here you can see same, we can start MCP inspector and select the transport type as SSC. And the URL is 8181. By default, the endpoint is /SSC. So let's go ahead and change it to SSC. And yes, we can see the details already here. Let's reconnect, and it is connected successfully. List resource, no, here clear list tools we can see. And let's put a breakpoint to make sure that it is actually invoking our application endpoints. So here I'm going to put a breakpoint in here and go ahead, get all this. So as you can see, it invoked our application tool. So let's proceed, and you can see the data. So that is how we can create the MCP server, this time using Webflux. And also this is how we can use MCP inspector to verify that tools, and you can invoke the tools accordingly. Okay. Now let us take a look at how we can build a client application. So far we have used Claude Desktop as the client tool, where we configured what MCP servers we would like to interact with and all that. And then we chat with LLMs from Claude Desktop, which is a client application. Now, instead of using Claude Desktop, let's say we are building some web application, and from that we want to use these MCP servers. So our Spring Boot application will act as a client. So how do we build this client? So let's take a look at the POM file. Here I am building a web application. In addition to that, this application is going to act as a MCP client. So I have this starter client as well. And in this application, I'm going to use Ollama, but you can use OpenAI or any other thing. And these are the key dependencies. And if you take a look at the application properties, again, we configured the Ollama configurations, which model we'd like to use and all that. And important thing is we have configured the client standard IO servers configuration. So either we can directly configure using the properties itself, or we can use a JSON file to configure. And this is similar to how we configured using Claude Desktop configuration. So here I specified this is the JSON file that contains all the MCP servers configuration. If I take a look at this MCP servers JSON file, As you can see, this is exactly how we configured in the Claude desktop. I configured the same server name. You can change it if you want and give the same details. Now, once I have this configuration, how do we make this MCP servers available? So in a video controller, this is a REST API controller I have, and while building this chart client, in addition to building this default advisor, we have talked about it earlier. So here I am injecting this tool callback providers and then passing it to default tool callbacks. So all the tools that are configured in these MCP servers, here we have only one, but you can configure multiple. So all the tools available in this is going to be available to this chart client as well. So here, if I ask a question that says, okay, what are the videos available on SivaLabs channel? It should know, okay, I need to invoke the tool from that SivaLabs MCP server and call that. Okay, so this is pretty much, we have already seen how to do this, but the key point is to hook up this tool callback providers into this one. Either you make it available as a default tool on a chart client, or you can also pass for a specific invocation as well. Okay, now this is all the key configuration. Now let's go ahead and start the client application. Here I am starting this. And make sure this is important, like where you have your jar file, it should have the correct path. So now I have started the application, and let's go to localhost 8080. This is my client application. Now here, let me ask, so I'm hoping this is going to use SivaLabs MCP server and fetch the data, and it should show what are all the videos available. As you can see, it shows all the response that it got from MCP server. So that is how we can build an MCP client application and configure what are all the MCP servers that we would like to use from this client application. So imagine you are building a help desk application and you want to leverage different MCP servers. So in this case, we are using this MCP server. But as I mentioned, we can also directly configure a Postgres MCP server and you can query the data. So it is this is how you can configure which MCP servers you would like to use from your client application. And in this case, we are using standard IO protocol. Okay. Next, let us take a look at how we can build an MCP client using Webflux. So this is the final application that we are building, MCP client Webflux. It is kind of a similar to MCP client standard IO, but in this time, instead of using simple MCP client, we are using MCP client Webflux dependency, which is going to use Webflux based communication with the MCP servers. Okay, and we are using Ollama. And if you take a look at the configuration, we have Ollama configuration that is common, but this time earlier we have stdio and connections information, but in this case we are using SSE based connections, and I am giving a name to the MCP server here itself, SivaLabs, and I am specifying where is this MCP server running. As you remember, this application I have configured to run on port 8181. So here, so I am configuring that here. Okay, and the rest of the code is common, like in the video controller we have same tool callback provider injected, and you can make a call to this ask API endpoint from your application. And one thing to remember, because here we are making a call to this service, it should be up and running as well. Okay, so first let us go ahead and start the Webflux based server. So this is the one. Let's start. Okay, once it's started, Now let's go ahead and start our Webflux based client as well. And both are up and running. Now let's go and let's search for um, what are the videos available on microservices from SivaLabs. So from this application, it is going to talk to the Webflux based MCP server and get the information. As you can see, it made a call to this MCP server. Here we hit the breakpoint. Let's proceed, and it should get the data and format it in a human readable format and then show it in this web page. Okay, so there is only one tutorial on microservices, which is complete tutorial Springboot microservices one. So as you can see, we talked from client application built with Spring AI to a MCP server again built with Spring AI using Webflux using SSE based communication server sent events. So we have seen quite a bit in this video. We have seen how to build a server using a standard IO and Webflux, and we have seen how to implement a client using standard IO and Webflux based protocol, Webflux based thing. And we have also seen how we can use MCP servers from Cloud desktop as well. And also we have seen how we can leverage this MCP inspector tool to interact with the MCP servers that we are building locally. So very handy tool. So I hope this video gave a gist of what this MCP protocol is and how we can build MCP server and client using Spring IO. So this is it, and I hope you enjoy this series and you got good understanding of core Spring AI concepts, and you should check out this repository. And here we have all the code samples that I have gone through in this series. You should be able to check out and then run yourself. So I hope this series is helpful, and thanks for watching. Bye bye.